Hello, my name is Jason LeBlanc, and the topic of today is projectile motion. Here you have John Barnes Jr. and Isaiah Johnson. And we're going to use projectile motion to find the maximum height he needs to shoot over his opponent, which will be Isaiah. And right here, B is going to be the maximum. And he's going to have 4 chances to shoot the ball into the proposed target, which is the trash.
I'm Isaiah Johnson, and this is...
Hello, I'm Johnny Boy.
Alright. John has 4 tries to make 4 paper balls into that trash can with my hand in his face at an 80-degree angle going 10 meters per second.
Notice, I gotta shoot at an 80 degree over his head. I made it.
No.
This. Alright, hold on, I'm gonna try again. Let me try again. I made that one. No, I'm trying. I made that one. No. Hold on, I got this one. Doctor Store. I did that one. I made that one. It's all about store.
Hi, I'm Tessia Franklin,
I'm Lauren Rutherford.
and we're going to explain to you the max height that John had to shoot over his opponent. So we were given the velocity of 10 meters per second, and we're trying to find the max height in the y direction, and the initial velocity in the y direction was not given, so we will have to calculate it using v times sine theta. So Vy will equal 10 meters per second times sine of 80 degrees. I got the 80 degrees because it was given by Isaiah, because John had to use 80 degrees to shoot over his opponent. So multiply that. According to my calculations, the initial velocity was 9.8 meters per second. And then the final velocity will be 0 meters per second because it landed in the trash can. And our acceleration in the y direction will be negative 9.8 because it's going in the y direction and the gravity is pulling it down. And again, our theta degrees is 80 degrees.
Now that we have all of the given variables, we're going to plug it into this equation to find the maximum height. So you have the Vy final, which is 0, equals Vy initial, which is 9.8 squared, plus 2, and the acceleration, which is negative 9.8. And then you're solving for d. So 0 squared is 0, equals 9.8 squared, which is 96.04. Then minus 2 times 9.8, which is 19.6, and then d. So we're going to move the 96.4 over, so you'll have negative 96.04 equals negative 19.6d. You're going to divide each side by negative 19.6. And you'll get 4.9 meters as your height.
We have the second equation, and we have velocity squared, which is 9.8 meters per second squared times the sine of Isaiah,
80 degrees.
80 degrees. Ooh, yeah, squared. Over, need a new marker. 9.8 meters per second, which then gives you, hand me calculator. Or are you gonna do it? You gonna do it? All the way down.
4.75.
Which equals 4.75 meters.
The first equation equals 4.9 meters. The second equation equals 4.75 meters. Both answers are correct because they both round up to 5 meters.
Okay, these are a few definitions relative to what we're talking about, which is projectile motion. The first definition is of projectile motion, and it's a form of motion in which an object is thrown towards the Earth's surface and moves along the curved path. And then the second one is the law of inertia, and it's an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force.
And all of those put together is based on Newton's third law of motion. So for every action, there is an equal and opposite reaction. So basically, the quote, what goes up must come down.
Hello, my name is Jason LeBlanc, and I'm back again to summarize the projectile motion project. And we found that using the kinematic equation, the maximum height for the that is required for John to make the shot will be 4.9 meters. Well, thank you, and hope you enjoyed the video.